evaluate this triple integral where the region E is below the plane G equals X and above the triangular region with vertices 0, 0, 0, pi 0, 0 and 0, pi 0. So we don't have to graph or draw the region E, which is not easy always. Sometimes we are able to draw, but I'm not going to try here. But this triple integral can be always rewritten in this way. Okay, just dv first write in terms of g, then dx dy or dy dx. So this will be d, that's the projection of this E on to xy plane, and the third we are going from 0 to, because the xy plane it mentions about below the plane G equals x, so the upper bound for G is x, and above the triangular region with vertices. And if we look at the third coordinates here, 0, 0, 0, G is always 0. That means on the xy plane, that's why G equals 0. Okay, looking at the third coordinates. So we can always reduce this three-dimensional region into two-dimensional D, which is the projection of E onto xy plane, and inside just go for G. You don't have to go for G first, but I'm doing the way every single time, making this of type 1 if you know the types. Otherwise G first inside, and the outside D is just the projection onto xy plane, and we are much more familiar with the plane D. Okay, and the A. Now let's draw D. We have to draw D, the region on xy plane. So looking at these 3 points, just disregard the third because we are on the xy plane. So we got 0, 0, pi 0 and 0, pi. So this is a triangular region, and now we can find the equation of this line, y equals mx plus b. So it's going down, so slope is negative pi, that's the fall, pi over pi, so negative 1 x plus b. B is the y-intercept, which is pi. Okay, using y equals mx plus b, because this is pi 0, this is 0, pi, 2 points, we can find this equation. And now I want to make it like this. If you know the type, this is type 1. So I'm writing x in the last, and x goes from 0 to pi. So this d I'm going to write in this way. This is x and y. That means x at the last and dy, and we have inside. We don't have to write parentheses, but I'm just writing just to separate things. Sin y dg. Now x, this arrow could be taken anywhere in between 0 and pi. So x is 0 to pi, and y, that means the bottom of the arrow, which is the x-axis. That means the equation is y equals 0, and upper curve is this line, so y equals negative x plus pi or pi minus x, same thing. Now this is an iterated integral, and we should be able to compute using calculus 1. And this is x equals 0 through pi, y 0 through pi minus x. Now let's integrate. Let's integrate sin y with respect to z. Sin y is a constant because we are doing with respect to z. So sin y survives. Then we have 1 dz. Antiderivative of 1 is just the variable z. And we have limits for z, 0 to x. dy dx. X equals 0 to pi. Y from 0 to pi minus x. Sin y is there. Upper limit z equals x minus lower limit 0, x minus 0, which is just x, times x, or let me write here x, dy dx. Now we want to integrate here this function with respect to y. Okay, outside is x equals 0 through pi, antiderivative of this product with respect to y, but x behaves like constant with respect to y, so we can just pull outside. That leaves sine y. Antiderivative of sine y is negative cosine y, and we are evaluating from y equals 0 to pi minus x, and we have dx outside. X from 0 to pi, this negative can be pulled outside, by the way, negative x. Upper limit, replace y by pi minus x, so we get cosine pi minus x, minus lower limit, replace y by 0, cosine 0, which is 1. I pull negative outside, dx. Okay, now let me simplify. X from 0 to pi, if we distribute this, okay, this is negative x times cosine pi minus x. Interesting here, cosine pi minus x, you don't have to write the formula, but it simplifies. If you want to simplify cosine pi minus x, that is negative cosine x. Why? Okay, if you go in this rule, cosine 180 degrees minus x, that's in the second quadrant, 180 minus something, where sine is positive, cosine would be negative, so negative cosine x. In fact, you can get away just writing cosine pi minus x, no need to write, but that looks more complicated. Okay, so I'm using cosine pi minus x is negative cosine x, that makes this negative positive, so x cosine x, and next negative times negative positive, x times 1 x dx. Now we need to integrate this product using integration by parts plus integral of x, that's easy, x square over 2. So here, let me separate into two, maybe x, we don't have to write x anymore because x is the only variable we are left with. So 0 to pi x cosine x dx plus 0 to pi x dx. Okay, and this part is easy because antiderivative of x is x square over 2, and we go from 0 to pi. This is pi square over 2 minus 0, just pi square over 2. So here we need to use the integration by parts because we got a product. So let me pause the video, do integration by parts here, and write over here. So to use the integration by parts here, so let's go here. U is x, okay, and dv is cosine x dx. So du is just 1, and integrate v is sine x. And by the integration by parts, u v, so x sine x minus integral v du sine x dx. Antiderivative of sine x is negative cosine x, so that negative positive cosine x here. Now we want to evaluate this at the upper limit minus lower. Plugging in pi, we get pi times sine pi, which is 0, 0 plus cosine pi, which is negative 1. That's upper limit, minus lower limit, plug in 0, so this is 0 plus cosine 0, which is 1. Okay, and this is negative 1 minus 1, negative 2. Okay, negative 2 plus pi square over 2, final